Okay, I'll see you later. You don't sound too good. What's wrong?
It's those fraction problems. They are just driving me crazy. I'm trying to get ready for this test I have to take for a new job, and if I don't learn how to do fraction problems by that time, I'm going to be in big trouble.
Well, don't get all upset. Fractions aren't that bad.
Maybe not for you, Sue, but you're good at math. I'm not.
Well, didn't any of that stuff that we did in class help you any?
Not really. Not when I got home. I just got all confused. I'm trying to find Frank so that maybe he can help me with this stuff.
He left a little while ago. I saw him when I was downstairs.
Oh, no.
Hi, Jean.
How am I going to learn this stuff?
I don't know.
Sue, maybe you can help me.
I wouldn't mind trying, Martha, but I'm sure not much of a teacher.
Well, maybe you can just show me how you do the problems.
I really don't know.
Please, Sue, just try.
Okay, but we need to find a blackboard so I can show you, okay?
I really appreciate this, Sue. I want that new job very badly, and I don't want to mess up on this test.
Well, even if you don't know all about fraction problems, I'm sure you'll do wonderful on everything else.
Maybe, but I just don't want to take a chance. And if I'm worried about the fractions, I'm not going to be able to concentrate on anything else.
Look, tell me what fraction problems cause you the most trouble.
Well, one's like this. 3/4 plus 5/9.
Okay, 3/4 plus 5/9. Now, first you have to find the least common multiple. Remember how Frank was talking about equivalent fractions?
Sue, please, don't go over that again. I have been over it, and it just makes no sense to me at all.
But, Martha, first you have to find the least common denominator when you're adding these types of fractions.
Oh, see, it's just impossible. I'm never going to learn enough to get anything in that test.
It's not hopeless. You just need somebody who... Why don't you go talk to David? He's good at explaining math to people.
Spencer?
Yeah.
I've never even talked to him.
Oh, I've been in to see him before. He's real nice, and he's good at explaining things to people. Look.
Do you think he'll be all right?
Take all this stuff and go see him.
Oh. I don't feel like it's...
Martha, get going. He's right down the hall, and he won't mind a bit.
Mr. Spencer, could I see you for a moment?
Sure. Come on in.
If you're busy, I can come back later.
Oh, no, that's all right. Come in, have a seat.
Thank you. Oh, I'm Martha Proctor from the math class.
Of course, I remember you, Martha. What can I do for you?
It's fractions. I listened to everything Frank told us, and I did all the adding and subtracting, and I worked on that chart.
Right, equivalent fractions in number family, huh?
Uh-huh. But the more I thought about all that, the more confused I got. I just don't understand how to work fractions.
I'm not surprised. That was nearly a complete course in number theory.
I don't know what it is about fractions. I couldn't do them as a kid, and I can't do them now.
Well, you're not the only one with that problem.
But I've got to learn them now. Next week, I'm going to be taking a test for a new job, and I'm sure fractions are going to be on it. Do you think you could try to explain it to me again?
Suppose I told you that all that stuff you talked about in class really wasn't necessary. Would you believe me?
Yes, if you say so.
Kind of make you wonder why you went to all that effort, wouldn't it?
Well, yes, if it isn't really necessary.
There's always several ways of doing things. If you're having trouble with all that stuff, just forget it. We'll try a different approach.
Forgetting it is going to be easy, but
Frank was trying to give you a set of numbers, a set of rules. We'll try to help you build your own set of rules.
My own rules? How am I going to do that? I don't even know enough about fractions to be able to do anything.
Come over here to the think tank. We'll get started.
What am I supposed to do?
First, I want you to write 1/3 plus 1/3. You can add those, can't you?
Sure.
Okay.
It's 2/3. But see, that's easy because the denominators are the same. Then all you do is add the numerators.
Write this. 1/4 plus 1/5. Does that kind confuse you?
Yep. The denominators are different and I'm stuck already.
Okay, just look at it carefully. Don't tell me how you get the answer, but believe me, the answer to the problem is in the problem itself.
The answer to the problem is in the problem itself?
1/4 plus 1/5 is 9/20.
9/20. But how?
I guarantee you that 9/20 is the answer, and both those numbers are in the problem. Do you see them in there anyplace?
Well, I can get 9 if I
Well,
just...
don't tell me how you get it. Just tell me if you see a 9.
Yes, I see a 9.
Okay, that's all that's necessary. Okay, do you see a 20 in there anywhere?
Well, yes, I guess so.
Okay, don't tell me how you found the 9 or the 20. Just, do you know how you found them yourself?
Yes.
Okay. If I give you another example, will you promise to do exactly the same thing again?
I guess so.
Okay, I want to make sure you do the same thing again. Can you?
Yes, I can do it.
Okay. Try 1/6 plus 1/5. What numbers do you see in there? Do the same thing you did before.
I see 11 and 30.
Okay, which one goes where?
11 over 30.
That's right. See how easy it is?
Is that really the right answer?
Sure. Well, let's try another one. 1/8 plus 1/3.
Um, 11/24.
Right again. I thought you told me you couldn't do this. You must have some system.
I do, but there's got to be more to fractions
No.
than this.
Well, these have been easy examples, but you're definitely on your way.
Now, can I tell you how I got them so that you can tell me whether I'm right?
All I want you to do right now is just remember the next example. It's going to be the model for the rest of your life.
Oh, boy.
Okay, so memorize it. Okay, 1/4 plus 1/3.
7/12.
Okay. Leave it up there and memorize it.
Okay.
Okay?
1/4 plus 1/3 equals 7/12.
I know your system, and I'll bet you're missing a few things, but don't worry about it right now. Okay, what's your model again? Don't look.
1/4 plus 1/3 equals 7/12.
Okay. Hang on to this, and we'll try the next hurdle now. When you get over that, you're all set.
I'm ready.
Okay. Write this problem. 2/3 plus 1/4. You already know the denominator, don't you?
12.
Okay. What number goes over 12?
7?
No, but don't get uptight now.
But I did the same thing as I did before.
I know, but there's something different about this one.
What's different?
Look very carefully.
Oh, I see. It's 2. 2 in the numerator. All the numerators were 1s before.
And what did you do with the ones before?
Nothing. I just took the denominators and...
Now, don't tell me how you did it, no matter what you want to. Don't tell me how. Now, just think, Martha. You had ones in the other problems. You can't just ignore them. If they're there, you have to do something with them.
But I didn't before.
You just think you didn't.
I know I didn't do anything with them before.
Okay, we'll see. Back to our problem. You did the denominator perfectly. But the number on top, the numerator, is 11.
11? How did you get that?
Believe it or not, 11 is in the problem. You just have to work harder to see it.
11. How?
Use your detective skills. You can find 11 in there someplace. Can you manipulate the numbers to come up with 11?
Well, if I multiplied
Now, don't tell me. Just check through your system the way you did before. Do you need to change in any way to come up with 11 for the answer?
I'm not sure.
Okay. If you think you have a clue, we'll try this next example, okay? 3/8 plus 1/6.
48 is a good denominator.
Right.
Okay, then if I do what I did before, I get 26.
Wonderful. Try the same thing with 2 7s and plus 1/3.
Okay, I can see right off the denominator is going to be 21. Then I get 6. 13/21 has got to be the answer.
You bet it is. There are only 2 more cases to handle, and you'll have discovered all the possibilities. Aren't you proud of yourself? Okay, let's go back to the beginning. I want you to tell me what you know already before we go on. Okay, what's your model?
1/4 plus 1/3 equals 7/12.
Okay. I'm going to ask you some questions, and I want you to answer yes or no.
Okay.
Nothing else. Okay. To solve this problem, did you use multiplication?
Yes.
Did you multiply twice?
No.
Did you add anything?
Yes.
Okay. Now, Martha, I want the first one to work exactly like the second kind. Like this one here. Okay? Ready for some questions about the second kind?
Yes.
Okay. Did you multiply something?
Yes.
Did you multiply twice?
Yes.
Did you add anything?
Yes.
See the difference?
Well, I multiplied twice to get the second answer, and only once to get the first one.
Martha, listen carefully. I multiplied twice to get the answers to both questions.
You did?
Mm-hmm.
Sorry, you'll have to guess what Martha and David are talking about. Hi, I'm Steve Wise. Here are the key problems that gave Martha the clues necessary to follow what David was showing her. 1/4 plus 1/3 equals 7/12. How can you get 7/12? Here's another example. 1/2 plus 1/3 equals 5/6. Do you know the clues Martha was using, and could you use them in this example? In the second example, Martha had to do something slightly different. 2/3 plus 1/4 equals something over 12. 8 plus 3 equals 11. 2/3 plus 1/4 equals 11/12. She found the denominator by the same process as in the first example. But to get the numerator, she said she added 8 and 3. How did she get 8? How did she get 3? Study this problem. 2/3 plus 1/5 equals 13/15. One of the secrets to adding and subtracting fractions is in these questions. Stay tuned for more clues.
With the information you have now, Martha, this next case should be easy. You ready?
Uh-huh.
Okay. What are 2/3 plus 3/5?
2/3 plus 3/5 equals... There are no ones in the numerators at all this time, huh? Okay. The denominator is 15. The numerator is 10 plus 9 equals 19. 19/15 is the answer?
Excellent. See how quickly you picked that up? But let's try one more for practice. Okay, what's 5/6 plus 2 7s?
5/6 plus 2 7s equals... The denominator is 42, and the numerator is 35 plus 12 equals 47. 47 over 42 is
That's
the answer?
it. You got it. Okay, now I want you to erase everything off the board.
Everything?
Everything. I'm going to give you your 3 key problems again. And once you memorize them and the answers, you'll be able to add any fractions.
Okay, if you say so.
Okay, you ready? Here's the first one. 1/4 plus 1/3 equals 7/12.
1/4 plus 1/3 equals 7/12.
Okay. 2/3 plus 1/4 equal 11/12.
2/3 plus 1/4 equals 11/12.
And 2/3 plus 3/5 equal 19/15.
2/3 plus 3/5 equals 19/15.
Okay, memorize those. And remember that the answer to the problem is contained within the problem itself. And you can add any fractions you come upon.
Just by remembering these?
Mm-hmm. You've already learned how to solve any addition of fractions problems. Plus, if you'd like to, you can do subtraction.
Subtraction? We haven't even talked about subtraction. How am I going to do subtraction?
Now, you've learned to be a better detective. Try this on for size. 3/4 minus 2/3.
3/4 minus 2/3 equals... Well, I guess the denominator stays the same, 12, right?
Good.
Then if I do the same thing as I did before, I get 9 minus 8. Are you trying to tell me that all I have to do is take 8 away from 9 and that's the answer?
Now, what are you telling me?
I think so.
You think right, too. Aren't you proud of yourself?
Well, I am, sort of.
Okay, I think we do 2 more, and it'll be engraved in your brain forever.
Let's try 7/8 minus 2/5.
Okay, you can do that.
The denominator is going to be 40, and the numerator is 35 minus 16 equals 19. 19?
Right. You want to try another one?
No. I'm tired. But you know, I feel like I can really add and subtract fractions now.
Of course you do. And you figured it out yourself.
It does look as though Martha has figured out the system. Have you got it yet? If you are forgetful, like me, write down this information. Keep it in your billfold or purse and look at it from time to time. The first example is 1/4 plus 1/3 equals 7/12. Now think, 4 times 3 gives you the denominator, and 4 plus 3 gives you the numerator. The next example is 2/3 plus 1/4 equals 11/12. Think again. 3 times 4 gives you the denominator, and 8 plus 3 gives you the numerator. Now for an example using subtraction. 3/4 minus 2/3 equals 1/12. Think about this one. Multiply 4 times 3 to find the denominator, and subtract 8 from 9 to find the numerator. Remember that every problem involving addition and subtraction of fractions can be solved if you know the math behind these 4 examples. If you are still a little unsure as to how David and Martha are doing the problems, let's watch the next scene. It should become more clear.
You know, I might as well get this all over with at once. You said there was one more pattern. What is it?
There is one more. Sometimes you'll have problems where you don't have enough numerical information.
Well, you're right. I often don't have enough information.
Suppose I ask you to solve this problem with your additional information. A over B plus C over D. Now, what kind of answer would you come up with?
You know, this is always happening to me in class, too. Just when I think I've got the whole story wrapped up, they throw some algebra at me.
Well, I think it'd be stretching the point to call this algebra. But in any case, don't let the letters scare you.
They scare me anyway.
It's being afraid that defeats you. These letters shouldn't bother you. Just work it normally as you would any fraction addition problem.
Well, then I guess the denominator is B times D?
Exactly. You write it in.
Now, I don't know how to say what the numerator is, but it's A times D plus B times C.
Wonderful. A times D plus C times B. This is the way it's written. We just say AD, CB, BD. That means multiplied by. We don't need to use multiplication symbols.
I see. Okay.
This is the formula for what you've been doing. It tells the whole story.
Yeah, I guess that is what I've been doing.
And look, Martha, you worked it out yourself. So if you forget it, all you have to do is work it out again. You've done it so many times that you can do that very quickly.
If you have time, do you think we could go over everything again? You won't believe how forgetful I am.
Sure, I've got lots of time. And this time, I'll even let you tell me what you're thinking.
Oh, great. Well, now, on this first one, I multiplied the two denominators in order to get the new denominator. And then I added them to get the numerator.
Do you know what you did that kind of got you off track?
Mm-hmm. But not until I worked the second one.
Let's look at the second one. Maybe we can find out how your initial thinking was a little bit off.
Okay, in this one, the denominator remains the same. 3 times 4 equals 12. But in order to get the top number, I multiplied 2 times 4 and then added 3.
Okay, now this is where you and I disagree. On the first one, I kept thinking 1 times 3 plus 1 times 4. Since I was multiplying by 1, it didn't make any difference. It didn't matter where I was cross-multiplying or not.
Oh, all right, I see now. Now, that's true even for the second case. 2 times 4 plus 1 times 3. I'm still adding 8 plus 3.
Yeah, I've used this system all the way through. And since I was multiplying by 1, it didn't make any difference in the outcome.
Now, this third one was simple, and so was subtraction. I just multiplied the denominators to get the new denominator, and then I cross-multiplied the first numerator by the other denominator and added it to the other cross-multiplication, right?
That's right. Neat, huh?
It's so simple. Now, why don't they teach us this in school?
Sometimes they do. They have what we call a general case method. It's great for most fractions, but it works best for simple ones.
I work best with simple ones, too.
Now, in this case, in this system, you must remember that sometimes you need to reduce your answer to the lowest possible terms.
You mean that should be 1 and 4/15?
Right.
Most fractions have pretty small denominators, though, don't they?
Of course. So for everyday encounters, the general case method works fine. That's about it, Martha. I think you're in good shape for your exam.
That was hard. But I really feel better about fractions now. Thanks so much for your help.
That's what I'm here for. Drop by any time.
If you memorize Martha's model problems, you'll be able to add or subtract fractions. Look at the models again. 1/4 plus 1/3 equals 7/12. This is the one that Martha did wrong, but arrived at the correct answer anyway. Remember, to get the new denominator, multiply the two denominators together. And to arrive at a new numerator, cross-multiply one numerator by the other denominator and add it to the other cross-multiplication, as in the next model, 2/3 plus 1/4. Multiplying 3 times 4 gives you the denominator of 12. To find the numerator, multiply 2 times 4, which gives you a product of 8. Then multiply 1 times 3, which gives you a product of 3. Then add 8 and 3, which will give you a numerator of 11. This same process will hold true for all addition of fraction problems. And, of course, subtraction works the same way. Here are a couple of Martha's subtraction models. First is 3/4 minus 2/3 equals 1/12. Remember that the same thing applies in subtraction as does in addition. To find the denominator for 3/4 minus 2/3, multiply both denominators, 3 and 4, which gives you a denominator of 12. To find the numerator, cross-multiply numerators by denominators, but subtract the products. For instance, 3 times 3 minus 2 times 4 equals 9 minus 8 equals 1. Your answer, of course, is 1/12. Our next example is 7/8 minus 5/6, which equals 2/48 or 1/24. You will notice here that you should always check your answer to see if it will reduce. This whole process can be labeled as the general case statement. The formula for addition would look like this. A divided by B plus C divided by D is equal to the quantity AD plus the quantity CB divided by BD. And the formula for subtraction, A divided by B minus C divided by D, is equal to the quantity AD minus the quantity CB divided by BD. All right, that's enough for this program. We hope you have learned and enjoyed. This is Steve Wise saying, see you next time.
Local funding for GED on TV has been provided through a grant from the employees of DLH Industries, manufacturers of fluid, air, and vacuum delivery systems for the automotive industry. DLH, committed to excellence in manufacturing and